What's up, everyone? So as promised in, well, my Surds and Indices questions, I said that we would have a separate lesson on harder questions, and so by the end of this session you should be able to answer exam questions. So let's start with the indices because we did that first. How do we simplify fully a question that looks like this? Well, remember what we learnt about laws of indices? A to the inverse is simply going to be 1 over A. So therefore, right, 64 x to the 6 over 25y squared, all to the inverse half, is just going to be 1 over all of that, so 64 x to the 6 all over 25y squared to the half, which is the same as just flipping that over, which is 25y squared all over 64 x to the 6. Now, we're also, remember, that whenever we have a to the minus a half, just the half, it's going to be equal to the square root of whatever we have, square root of a, and also, by extension, a to the x is the same as ax. So it's just multiplying those two indices. So let's use that to our advantage. That's going to be to the half. 25y squared over 64x to the 6. Well, let's take a look at it. What's the square root of 25? The square root of 25 is simply 5. What about this y squared? What's that going to be when we times it by a half? It's just going to be equal to y. And we're dividing it by 64. What's 64 square rooted? It's just going to be 8. And then finally, x to the 6 times a half. 6 times a half is just going to be equal to x cubed. And that is our final answer. We can also use this rule to answer equations that look like this. Write 16 times 8 to the power of 2x as a power of 2 in terms of x. Well, remember what we said? A to the b times x is simply a to the bx. So we can say that. We can use this to our advantage. We want it all as a power of 2 to the x, right? This is how we want to leave our answer. Well, now what we need to do is just make these based on 2. So we know that 16 is equal to 2 to the power of 5, right? And 8 is equal to 2 cubed. So therefore, 16 times 8 to the power of 2x is the same as 2 to the power of 5 times 2 to the power of 3 all to the power of 2x. And now we can do the rules as follows. So 2 to the 5 is just going to be 2 to the 5, and we're multiplying it by, what's 3 times 2x? 3 times 2x is 2 to the 6x. And remember the law of indices that we discussed in the previous episode. A to the m times a to the n is simply going to be a to the m plus n. So therefore, this is the same as 2 to the power of 6x plus 5. And that is our final answer. It even works when we have to solve equations. So for this one, we have multiple different bases, but we can make all of them be based 2. So what did we discuss before? We were told 16 is equal to 2 to the 5, and 8 is equal to 2 to the 3. Yeah. So therefore, 16 to the power of 1 over 5 times 2 to the power of x is the same as 8 to the 3, 4. That implies that, because we're just using the rules of indices, 2 to the power of 5 to the power of a fifth times 2 to the x is equal to 2 to the power of 3 to the power of 3 over 4. And now we can use our laws of indices before. So what's 5 times a fifth? 5 times a fifth is equal to 2. And we're timesing it by 2 to the power of x. And it's equal to 3 times 3 is 2 to the power of 9 over 4. And finally, when we multiply, what do we get? We have to add them, don't we? So 2 to the x plus 1 is equal to 2 to the power of 9 over 4. And now, because our bases are the same, and this is important, because only our bases are the same, this will be equal to this. So x plus 1 is equal to 9 over 4. And now we can solve for x. So x plus 1 is equal to 9 over 4. If we minus 1 on each side, x is equal to 9 over 4 minus 1, which is the same as 5 over 4. And that is our final answer. What about the surds? So let's say we were told something like this. Show that 1 over 1 plus 1 over root 2 can be written as 2 minus root 2. Remember what we said before. When we rationalize the denominator, we need to use a difference of 2 squares. When we have a 1 over root, it's exactly the same as how we did it in the last class. So 1 over 1 plus 1 over root 2 is the same as 1 over 1 plus 1 over root 2 times, and then we use a difference of 2 squares. So it's going to be 1 minus 1 over root 2 over 1 minus 1 over root 2. And then we multiply the as if they were brackets. So the numerator is simply going to be 1 minus 1 over root 2. And then we're dividing it by 1 times 1 is equal to 1. 1 times minus root 2, 1 over root 2 is just going to be minus 1 over root 2. This will be plus 1 over root 2. And then we times 1 over root 2 times 1 over root 2, that's just going to be minus 1/2. And then because we rationalize the denominator, these two will cancel out. And so what we're left with is 1 minus 1 over root 2, all divided by, what's 1 minus 1/2? 1 minus 1/2 is simply 1/2. Yeah? And now that's the same as writing 1 minus 1 over 1/2 times, and remember we're keeping, remember from our fraction classes, we keep, we flip, and we change. So this is the same as 1 minus 1 over root 2 times 2, which is the same as 2 minus 2 over root 2. And remember what we said before, that we can't leave it like this. Actually, I'm going to do this up here. So this is 2 minus 2 over root 2. So this is a problem because we have a fraction on the bottom. So what we can do is we say that 2 over root 2 is the same as, when we rationalize the denominator, 2 over root 2 times root 2 over root 2, which is the same as 2 root 2 over 2. And as you can see, the 2's will cancel out, so we're left with root 2, and therefore 1 over 1 plus 1 over root 2 is equal to 2 minus root 2. So all we needed to do was just rationalize the denominator as if it were a double bracket, like we did before. And then we need to rationalize the denominator as if it's just one surd that we're trying to rationalize. What about something like this? So for this one, we're told, work out what root 18 minus 28 over root 50 is, giving your answer in the form root a minus b. So let's look at what we have. Root 18, as we mentioned in the last class, that can be written as the square root of 9 times the square root of 2. Which is the same as, what's the square root of 9? The square root of 9 is 3. It's 3 root 2. And this root 50 can be written as the square root of 25 times the square root of 2. Sorry. So if I rewrite that, that's the same as root 25 times root 2. What's the square root of 25? The square root of 25 is 5. So that's 5 root 2. So now we can say that root 18 minus 28 over root 50 is the same as writing 3 root 2 minus 28 over 5 root 2. And now what we can do is we can multiply both. We can say that this is the same as over 1 because it's a non-fraction and we're adding a fraction, and then we're going to times top and bottom by 5 root 2. So this is the same as 3 root 2 times 5 root 2 over 5 root 2 minus 28 over 5 root 2. And now what is 3 root 2 times 5 root 2? 3 times 5 is 15. Root 2 times root 2 is 2. So that's the same as 30 over 5 root 2 minus 28. Minus 28 over minus 28 over 5 root 2. And now because our denominators are the same, we can subtract 30 from 28. I'm going to go over here just to have more space. So 30 minus 28 5 root 2 5 root 2 is the same as 2 over 5 root 2. And now because we have a denominator on the bottom, we're going to have to rationalize the denominator. So that's the same as 2 over 5 root 2 times root 2 over root 2, which is the same as 2 root 2 all divided by, what's 5 root 2 times root 2? 5 times 1 is 1, 2 times 2 is, root 2 times root 2 is 2. So it's going to be over 10. And then we can divide each of these by 2. So we're left with root 2 over 5. And that is our final answer. So all it comes down to is simplifying this, and then we rationalize the denominator at the end. Okay, what about something like this? Well, for this one, what we can do is we can... Sorry, I just went back a slide. First thing we need to do is we can rationalize... We can either rationalize the denominators, or we can solve this as if it were a normal fraction. So what is the lowest common multiple of 10 and 5? Exactly, it's 10. So what do we need to multiply this fraction by to get root 10? Exactly, we just need to get rid of, we need to do times it by root 2. So 2 root 6 over 5 over root 5 minus root 3 over root 10 is the same as 2 root 6 over root 5 times root 2 over root 2. And then we're minusing root 3 over root 10. And so what we're left with is, what's 2 times 1? 2 times 1 is 2 times 1 is 2. 6 times 2 is 12. We're left with 2 root 12 over root 10 minus root 3 over root 10. Now, we can subtract 2 root 12 by root 3, but what is root 12? Root 12 is the same as root 3 times root 4, which is the same as, what's the square root of 4? Square root of 4 is 2. 2 root 3. 2 times 2 root 3 is equal to 4 root 3. And so therefore, we can rewrite this as 4 root 3 over root 10 minus root 3 over 10. And now, because our surds are the same and our bases are the same, this is supposed to be square root, we can now subtract one from the other. What's 4 minus 1? 4 minus 1 is 3, so we are left with 3 root 3. And we're dividing by root 10. And now we can rationalize the denominator. So that's the same as 3 root 3 over root 10. And we're timesing both sides, top and bottom, by root 10. So we're left with over 10. What is root 3 times root 10? Root 3 times root 10 is 3 root 30. Yeah. And we can't simplify root 30. So therefore, this is our final answer. Do practice these, as they do get a little bit tricky in the exam, and they're usually worth quite a bit of marks. Thank you guys for watching. If you enjoyed, make sure you smash that subscribe button. And if you need further help, join my Discord server. And if you need any tutoring, drop me an email. Keep on learning, as you have no idea what you're capable of doing.